it's a pleasure to also talk a little bit about the way we think about innovation in AEC, coming from a team that does not really have any architects at its lead, and is mostly with a background more in like applied mathematics, computer science, and trying to develop tools that in the end will be useful to the AEC industry, but way beyond. Since we started Shapediver a few years ago in 2015, as some of you might know, we've had a lot of pull from a lot of industries that we did not foresee coming. And I'm actually aware that more and more other industries are, jumping on the bandwagon and really investing a lot of effort into integrating parametric and computational design in their workflows. And as such, what we are trying to do is to tackle a lot of different types of workflows. Like watching what Grimshaw was talking about, we've had very complex workflows in AEC projects. At Shapediver, we started with the very simple type of configurators that the guys were talking about, and now we're really trying to find the way to bridge those two worlds and all the use cases in between. So that's what led, and also following obviously the merger with Swarm. That's what led us to rethink a bit the whole infrastructure of our tools and the way to approach all of these problems and interoperability, let's say, as a whole. So I can show a little bit. I mean, I just have a quick that's just more of a proof that we're working on changing everything, and the front end is like the tip of the iceberg, but the platform is evolving a lot, and as you can even see here, we're focusing more on sharing, collaborating features, which is what we're talking about more today. So at its core, also as a reminder for everyone who is not so familiar with Shapediver, I mean, we started doing Grasshopper in the clouds years ago. So since then, Rhino Compute became available, and it made it even easier and more convenient for us to develop a lot of tools around, remote solving of parametric algorithms. So at its core, what our service is a way to upload Grasshopper models, but it's really agnostic to the parametric workflows that are used in the backend and really can be adapted to anything. And essentially, it's a secure, reliable, and scalable infrastructure for casual uses up to very industrial, like heavy uses. So some of our users in the product design department have sent us tens of thousands of users per minute when they have a lot of customers and they have marketing pushes on their website. So we really put a lot of effort into making sure that this infrastructure is solid. And after years of starting from a web browser, a way to access the algorithms through essentially a web browser and some APIs, that's when we started thinking about, after talking about all these industries using our tools, thinking about bridging in a more explicit way to other types of tools and other environments. So of course we have the tools that are used in the AEC industry, like Autodesk Revit or SketchUp. But even going beyond this, Illustrator being used in all types of design environments. And, I put also AR/VR on this slide because the idea in the end is that we are turning the parametric algorithms into remote, sort of mini remote APIs that are very, portable and accessible through any client in the end. So what we call clients, the way you're going to consume the remote algorithms. And the way we tackled this issue and, a sort of genericity which comes with trying to tackle a lot of problems from a lot of different industries is, all comes to the way we manage data, right? And something that, as we were working on all these tools and as I got even a bit more familiar with some tools that I was not very familiar with. I got a bit mesmerized by Illustrator. I was really like a non-Illustrator users, and as just like in this video, just showing the type of workflows you can have in Illustrator, and those are workflows that essentially use very basic objects. The only object you're manipulating in this example is curves, and they are enriched with a structure, right? So those curves come with an order in a document, and that's all you need to develop, tools that seem simple in terms of UX, but include a lot of computational tools that are hidden, essentially, that are hidden away, and make it simple when really there's a lot of complexity. But what is complex is the way to handle the data, and not really the type of data that is stored. Again, it's just a set of curves and an order attached to them. So with this in mind, and with all the time we spent working with Grasshopper, it became clear that in terms of CAD data and more, Grasshopper provides a set of pretty generic objects that are compatible with a lot of different environments, that are not too idiosyncratic to a specific use case, but really make sense in a lot of environments. And the idea was to start rebuilding everything we have with this new file format, which we call SDTF, for structured data transfer format. Really not, I mean, it's very generic and can be extended with any type of data, but it is like focused on CAD data. And essentially, this file format at the moment is compatible with 90% of all the data types that Grasshopper supports as structured, right? So the file format in itself preserves the data structure that Grasshopper comes with, because that's the second really interesting point about Grasshopper, is on top of the set of data that's available there, is the way to manage this data and structure it, with items, trees, lists, etc. We extended the data types available in Grasshopper with a few more. Bitmaps are used a lot in a lot of different workflows and use cases, so we added that. Even PDF files, which is a bit more specific, and we enriched those data types with an attribute system, a very simple, very generic attribute system. So the idea is that if you have simple data with a structure and a simple set of attributes, you can do a lot, and you can essentially let Grasshopper do what it's best at, and not really and go parasite the other clients, the other environments, instead of having this like interconnection and in the end ask people to grow their field of expertise beyond the tools that they're comfortable with. So this file format, we published a first version of it on GitHub. It's completely open source, and everyone's welcome to extend it. It's it follows some of the principles of the GLTF file format, which is the standard now for visualizing geometry on the web. Which makes it very efficient to access, very lightweight, but still very, very structured. So essentially, once we started looking at things this way, both the inputs and outputs of a Shapediver app, which is essentially a remote parametric algorithm, again, which can be created with Grasshopper, but potentially with any other tool that processes the same set of data, is that both the inputs and the outputs of these remote algorithms are SDTF assets in itself, which can even be stored in their own file format, right? So that makes it now very efficient to build, instead of building really huge tools with a single purpose, to build small and reusable functionalities across projects, across teams, and to chain them together, right? So really, the output of one app can be mapped in a very simple way to the inputs of the next. Maintenance becomes also very attractive while working like this, because as you deploy these apps, which are essentially just online Grasshopper models, and as they get deployed and consumed by people over, a set of clients, whatever tools are used in a team, updating those apps, fixing bugs, making them faster, adding functionalities to them, becomes very easy to version and to deploy to the users of the app. So I just recorded a quick, and those, if you want more detail about all of this, both the workshops we had last week go in some detail with the beta release that we're going to release imminently now. And in this one, you can see that we have our output components, which gets as a set of inputs, a set of structured data, right? Trees, items, list, everything. And you can save this set of data as an SDTF asset and load it directly. So that's more like a debug tool that we use to test, but it's a really good way to show how, how basically a remote app can very efficiently consume SDTF assets and produce them in return to give back computational results. And again, in any environment, which is what I will mention now. So once you have this, essentially that's let's say part of the design principles that we use to develop all of this, is that we're going to have a set of clients, right? We always had a web browser as a client consuming these assets, and that lets you request computations and get back the results. And now we have a way to add clients, desktop clients or any sort of clients. And essentially all these clients have to do is to have a strategy, both to format the data that they're going to send to the remote algorithms as SDTF assets, which are essentially extremely simple, structured data, very generic data types. And on the other hand, these clients have to, have a strategy to parse and consume the data that comes back from the remote algorithms. So the clients are really in charge of doing these two operations, which allows the file format to stay generic, to not be too augmented with very specific data types. And once you work with data types and you use obviously the structure and the attributes as hints to tell the clients how to consume this data, there's already a lot of interesting tools that can be built using this. So in terms of attributes, we have there's essentially two main types of attributes. We have a set of reserved attributes, which are the ones that are generic enough that they're going to make sense to have as reserved and used for a specific purpose in each client. So essentially, we have an attribute called name, which is obviously in the Rhino client going to be mapped with the name of an object in the document, and that name makes sense in most of the clients you can think about. Layers also make a lot of sense in most of the CAD's software that everyone here uses. And then we have clients that make sense in different environments, even though they don't always have the same meaning, right? So we've been using plot weight at Shapediver for a long time to export the XF files, plot weight, plot color, all of these type of attributes you can send when you export drawings. We're reusing those attributes in Illustrator, for example, to define stroke weight, stroke color, and added some more that right now are specific to Illustrator, but will make sense in other environments. But we can see that even like a simple attribute like color, which makes sense in Rhino, in Illustrator is not really usable. We have to go more in detail, and because you always have a stroke color and a fill color, for example, to describe essentially paths, which are the main object manipulated in Illustrator. And the rest of the attributes are custom, essentially, right? So you can in Grasshopper you can store, read of course, and store any key value pair that is added to enrich any type of data that is supported in Grasshopper. And those custom attributes is also clients also have a way to decide what they're going to do with them. So what we decided to do for the Rhino client is to map custom attributes with user text for the geometry that is baked and the geometry referenced as inputs of objects. But obviously, custom attributes will be linked to a different specific set of attributes or mechanism in all of the software that we're using. One example, so that's the first in my list here. One example where having structured data can become very interesting is to all the file formats, especially in Rhino. Rhino tends to import a lot of different CAD file formats with nested blocks like step files, the XF files, all of this. And you can easily preserve the nesting structure of the blocks by using trees in Grasshopper, right? So that's really also a good example of how structuring the data allows simple mapping in more cases. Yeah, I just listed a bit, like I was throwing ideas a bit. So material, we have a reserved attribute for material, but obviously this is very different in different clients, and we can selectively support materials. And yeah, a last point that I had, just to really keep giving an idea of the generic approach of these data types, is that even a point has a very different meaning in terms of how you manipulate it, how you input it, how you get it back, and what's the feedback when you get it back in your client. So even if you think just of Rhino, Illustrator, or an online viewer, it ends up being very different. So that's a way, that's one of the reasons and one of the things that made us think that leaving responsibility to clients and providing this very generic and flexible structured data type made sense. So I wrote down a few examples of how use cases that could make sense to use with this type of tool, right? So there's a lot of tasks that are cumbersome to do in Revit, and that can very easily be automated with a step in Grasshopper, right? So if we talk about a structural grid, for example, we can have a use case where you have a generic structural grid generator, which can cover simple cases, and let someone from a client inside Revit specify inputs in Revit and apply a structural grid to the concept. And for more custom grids, you can even imagine workflows involving three stakeholders, thanks to the sharing and the possibility to save the state of a specific online app, right? So a user in Rhino could save a specific state, inputting a set of curves as inputs to generate this structural grid, and then share this state with a Revit user or whoever, like a graphic designer if it's working in Illustrator, who can then apply the rest of the inputs and bake directly in their own client. So that's a bit the idea of this workflow here.
Give you about a couple more minutes, Mathieu.
Yeah, okay. I'll go quick, and anyways, I'll share the presentation. I had come up with a few examples of workflows, quick structural sizing. We already have use cases of people using the API to do these kind of things. Marketing and presentations obviously is a big example here, especially when we start having all these clients interacting with each other. And yeah, I had that was like just a workflow, like a video on YouTube where someone spends 20 minutes importing a design in SketchUp to Illustrator and formatting and working on it, and that can be done in a click of a button with the right Grasshopper algorithm. So I wanted to just show quickly the first beta of this of the Illustrator client, which is the first one we're about to complete, thanks to the work of the nice guys at Core Studio who worked with us very closely on this. Where you have, I created this very simple app that generates a Voronoi pattern from the boundary curve. And here you have an app that really has a curve and a slider as inputs of the app. And all you need to do with the new client is to tell Shapediver, these are my inputs, the curve and the slider. And as output, what I want is my cells. And here I'm showing how I inject attributes in the curves that define the cells to give them a different fill color. For example, that's the way I did this, just a different fill color, which can be interpreted by Illustrator. Then the Illustrator comes with a standalone client that can be connected with the Illustrator process, and any app that I've uploaded to my Shapediver account are there, or that people shared with me, which is a feature that we'll have a bit further in the future. And you can see the app is exactly as you built it inside Grasshopper, except of course now you can define a path inside Illustrator as inputs of the app and connect them directly to the clients. Obviously, update any other parameter of the app, and send the computation to the clouds, wait for the results to come back, and then bake them in Illustrator. And here is the client-driven strategy, where as the baking operation happens, Illustrator knows what to do with the fill color attribute and actually uses it as a as a native feature inside Illustrator. So yeah, I'll do this in literally 20 seconds. What's our timeline? We're releasing the new Grasshopper plugin with SDTF input and output imminently. It's really happening. The closed beta is going to start in a few days. We have full GLTF2 support on top of SDTF, which I didn't mention, but it makes it very powerful for web applications. The Rhino and Illustrator clients are going to be in the first version, and we already have a lot of development tools to start building all other custom clients. If you want to know more, you can look at the Shapediver AECtech workshop video that was recorded. A bit later this year, we'll make this more powerful by having more advanced sharing features, save states. Revit and SketchUp clients are the two next ones. We're going to work on it, and also advanced versioning, which not only lets you collaborate with people using different clients, but also makes it easy for several Grasshopper designers to collaborate on the same definition, which, as we all know, is extremely difficult, if not impossible at the moment.